Welcome back to our next lesson in our probability unit. Today we're going to be talking about compound probability. Probability, remember, is on a scale. You have all the way down here on the left, you have 0% chance, which is impossible. If you go all the way to the right, that is a 1 or 100% chance, and it's certain it's going to happen. In the middle is your 50-50 chance. That's your even chance. And if you go to the left, it's more unlikely that it's going to happen. If you go to the right, it's more likely to happen. When we talk about compound probability, if you think about a compound word just means it has multiple syllables. So with compound probability, it is just like the probability we've been doing in class, but we're adding multiple events, more than one event. So that's all we're going to be looking at. Our SOL has changed. We're now on SOL 7.10, and your job is to determine the probability of a compound event containing no more than 2 events. So for this SOL, we only have to do 2. There may be a couple questions where we throw 3 in there, but for your SOL, you're only going to have to know how to do 2. Remember the difference. Let's talk about the difference between simple and compound. Like I said, simple was when we had one event, we pulled one card, we rolled one dice, we spun the spinner one time. That's all simple probability. We talked about theoretical and experimental, and you know the difference of that. Today we're going to be working on just theoretical, or what should happen based on what we know, but we're going to be doing compound probability, which is the probability of 2 or more events. And the other thing you have to know is with compound probability, we have independent and dependent probability. So I know I'm throwing a lot of words at you, but we're going to explain what that means in just a minute. So another definition is a compound event is made up of 1 or more separate events. To find the probability of a compound event, you need to know if the events are independent or dependent. Independent means it happens by itself. The 2 events are not related. They don't change the outcome of either one. Dependent means that it depends on what happens. So a dependent event means that the outcome of the first one changes the outcome of the second. So if you look at independent events, it says that they are independent if the occurrence of one event does not affect the probability of the other. So it does not change it. It's independent. They're 2 totally separate things. And you'll see that when you have, they say, oh, I'm going to draw a card and then I'm going to roll a dice. Those are 2 totally separate objects that you're doing probability with, so they're independent of each other. They don't affect the other. However, dependent events are when the occurrence of one does affect the probability of the other. For example, if I say what's the probability of going to the library and selecting, Jeremiah goes in and selects a fiction book, and then Jalen follows him and picks a nonfiction book on drawing. So when Jeremiah took the book out and checked it out, there's one less book in there. So it affects how many total books there are to choose from. And that was a out there kind of example. But all right, if you take out your notes, this is page 13. We're going to look at our definitions first. So a compound probability is a calculation. Hopefully you can see that. I can write it over the top if you can't. It's a calculation to determine the likelihood of 2, and again, there's 2 types, independent or dependent events occurring at the same time. And when we say same time, we mean in close succession of each other, not like 2 days away from each other. Events can be classified as independent or dependent. We already talked about what those are, but let's go into more detail so you know some examples. So independent events Independent events are events in which the result of the first event does not affect the result of the second event. And the key words that I want you to highlight or underline, star, these are your key words that you're going to look for. Is with replacement, or if it's replaced, it's being put back into the sample, so nothing's changed. So, for example, Susie selects 2 chips from a bag of red and blue chips. If she selects a chip and she puts it back, then the next time she draws, there's the same number of chips as what she started, so they're independent of each other. So selecting 1 chip and replacing it before the next selection, that replacing, that tells you that it's independent if I've put it back, because the number of chips in the bag hasn't changed. Now, if we look at the next one though, dependent, remember, these are going to change. So it's the thing where, or the type of probability where the result of the first event does affect the results of the second event, or the event that follows it. And the keywords to look for here, and you're going to see this often, is without replacement, or without, not replacing it. Those are your keywords you need to look for. Because if like I gave you the example of the book in the library, if I go and check out a book, there's 1 fewer book in the library to choose from. So that is how dependent events work. So if there were 10 books to choose from, and then I select a book and take it and check it out, then the next person that comes, there's only 9 books to choose from. So the probability itself is going to change. So the example is Susie selects 2 chips, but this time when she selects 1 chip, she's not replacing it. Before the next selection, that's a key word. So let's look at some examples and see if you can determine. We've put in some dependent in here. We've put in some independent. We've put in some simple. Simple, remember, just means 1 event. So if you look at number 1, on a shelf, there are 60 novels and 20 poetry books. What is the probability that person A, Jeremiah, chooses a novel and walks away with it, and then person B, Jaylyn, walks up shortly after and picks another novel? So if Jeremiah has picked a book and walked away with it, he didn't put it back. So that would be a dependent event. So looking at number 2, what is the probability of getting a 7 after rolling a single number cube that has the numbers 1 to 6? I rolled 1 dice. So that is considered simple, and it's independent. All simple probability is independent because there's nothing for it to involve. Number 3, the numbers 1 to 20 are placed in a bag. They're on cards. Without replacing the first number, what is the probability that the first number drawn will be odd and the second will be even? I see 2 separate events. I've got the first number drawn, and the second number. So we want the first one to be odd, the second one to be even. But I'm not replacing the cards. And because I'm not replacing the cards, that is going to be dependent. So these last 4, I've done 3 of them for you, but the last 4 will be in your quiz today. You can go ahead and stop the video, read through them, go ahead and answer them so that you have them for the quiz online, or you can come back and do this when you do the quiz. Okay, if you flip over to the back of your notes, these are some practice ones. And again, we're only going to do part of them, and then you're going to do the rest for your quiz tonight. So the first ones are the independent events. What is the probability of flipping a heads on a coin? That's our first event. So I'm going to put, oops, I dropped my pen. Flipping heads on a coin, that's our first event. So I'm going to put that as my first fraction. And then rolling 5 on a dice, that's our second event. And that's going to go as our second fraction. Now, remember when you are doing compound theoretical, I didn't tell you this, but you're going to multiply your fractions together. And we will do some practice with multiplying fractions and reviewing that, but I'll go through and show you a little bit here in the video. So let's do the first event first. What is the probability of flipping heads on a coin? Well, we know a coin has two sides. So the 2 goes on the bottom because that's our total outcomes. And heads is only one of those sides. So my probability is 1/2. Now with a dice, remember a dice has 1, 2, 3, 4, 5, 6. And how many of those are a 5? 1. So the probability is 1 out of 6. Now all I have to do is multiply across. And when you multiply fractions, remember that you have to just multiply across. So multiply your numerators together and then multiply your denominators. 1 times 1, be careful, it's not 2. 1 times 1 is 1. 2 times 6 is 12. So that is my final answer. Now I put a little note over here and I don't want you to miss it. It says that you're going to multiply the probabilities together and then reduce the fraction if necessary. So, and I'm going to show you a little trick in a minute that how you can simplify before you multiply, and it'll make your job a little bit easier. Okay, so let's look at the next problem, and then I'm going to let you, I'll do the third one and you'll try the fourth one on your own. Okay, so for the second one, we have a spinner. And I didn't put it on here purposely because I wanted you to kind of think, but I'll draw it just so you can see. A spinner is round, typically. We have a red section. We have a blue section, a green section, and a yellow section. And that's what it says. A spinner is labeled with a red, blue, green, and yellow section. What is the probability, and I cut off, I'm sorry, of spinning green on your first spin and blue on your second? And I know that because how it's labeled here. So we've had 2 spins, and they're separate of each other on a spinner because the first spin doesn't take away any of our options. So if we look, what is the chance of getting green? Well, we have 1 green section out of 4. So the probability of green is 1 out of 4. And then it says, what's the probability of getting a blue? Well, there's 1 blue section out of 4. And like I said, they're separate of each other. So there's not any less choices. So their probability is the same. And then all we have to do is multiply across. So I'm going to do 1 times 1, which is 1. 4 times 4, which is 16. And that's my final answer. What happens if I say, what's the chances of getting 2 reds in a row? Well, how many reds are there? There's 1 red out of 4 options. And if I spin again, it's a separate spin. The probability hasn't changed. It's still 1/4. And you're going to do the same thing. Multiply across. 1 over 16 is your same answer. Okay, we're going to do one last example. And this one's talking about a drawer full of socks. And I know you guys are always getting dressed and you have all these clothes to choose from. That's probability. What's the chance of picking a blue shirt? Well, look at how many blue shirts you have in your closet out of how many total shirts. So let's draw a picture. We have 8 white socks and 4 gray socks. So here's my, I'll just draw some quick socks. 4, 5, 6, 7, 8. There's my white socks. 2, 3, 4. And these are my gray socks. They look like stripes, but that's okay. So if we look at this, how many total socks are in my drawer? There's 12 total socks. So now look at your events. First event, what is the probability of picking a white sock? Well, I have how many white socks in my drawer? 8. How many total socks in my drawer? 12. Now, I've replaced the sock. I put it back in after I picked that white sock. Now, what's the probability of picking a gray sock? Well, I have 4 gray socks out of, because I replaced it, I put it back, there's still 12 socks in my drawer. Now, this is where I want to show you how to simplify before you multiply. So if you look at these, I have 8 over 12. Those are both even, and I know that I can both of them are multiples of 4, so I can divide by 4 and simplify. So if I divide each of these by 4, I'm going to come over here and write the new fraction. 8 divided by 4 is 2. 12 divided by 4 is 3. And I can do the same thing with the second fraction. Divide them both by 4. So 4 divided by 4 is 1. 12 divided by 4 is 3. Now when I multiply, I get 2 over 9. That's my simplified fraction, and I didn't end up multiplying and getting these huge numbers that I had to divide and divide and divide to get the simplest fraction. If you can go ahead and multiply across and get 8 times 4 is 32. 12 times 12 is 144. You would have to keep dividing down until you got to 2/9. But simplifying before you multiply makes it a little bit easier. All right, the other thing is you can make it a percent, and then on your SOL, look at the answer choices and make it a percent. The only thing that's going to hurt you is if you don't have answer choices. All right, you're going to try number 4 on your own. Again, it's with replacement, so that means I'm putting things back. So you're going to figure out what is the probability of getting a gray sock and then another gray sock, and that'll be on your quiz. All right, now let's look at dependent events. Remember, this means that the outcome of the second event changes. So we're back to our drawer of socks. And with this, you're going to see like drawers of socks. You're going to see bags of marbles. You're not going to see anything with a spinner and a number cube because those are 2 totally separate objects, so they're not dependent ever. So these you're going to be looking for and drawing from the same bag, and look for the words not replacing or without replacement. So you can see that in each of these. Not replacing it, without replacement, without replacement, without replacement. You can see that, so you know those are dependent. Okay, so if we look at the first one, what is the probability of picking a white sock, not replacing it, and then picking a gray sock? So again, we know that the white sock is the first event, and the gray sock is the second event. So to go pick a white sock, look at how many total white socks we have. There's 1, 2, 3, 4, 5, 6, 7, 8. And then this would be 9, 10, 11, 12. So there's 12 total socks in our drawer. And you can put that up here, 12 total when we started. And how many of those are white? 8. Now, after I've done that, I'm not replacing that sock. So I took that white one out. So this one's gone. Now I don't have 12 socks anymore because I have one less. It's on my foot. So now I only have 11 socks in my drawer, and I want to look in how many of those are gray. Well, I didn't take a gray one, so there's still 4 gray ones left. Now, again, use your trick that I showed you. Simplify before you multiply. So I have 8 over 12, and I know from up above I can divide both of those by 4. So my new fraction would be 2 over 3, and I'm going to multiply that by 4 over 11. When I do that, 2 times 4 is 8. 3 times 11 is 33. And now let me go back to this, and I want to talk about why did I say there was 11? Because we started with 12 socks in our drawer. I took one out, and now I have 11 because that one's gone. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 socks left. So with dependent events, your second probability has one less choice. Now, did the gray socks change? not this time because I took a white sock first. But let's look at the second one and say what happens if I have a gray sock and then I'm trying to pull another gray sock. So let me go back because these are independent of each other. So 1 and 2 are not related. So we're going back to our original 12 socks. So I know for my first event I have 12 socks. What is the probability of pulling a gray sock? Well, if I look at my example, there's 4 gray ones. Now, what happens if I took one of those gray ones away? It's on my foot. What's the probability of pulling another gray one? Well, there's no longer 4 gray ones. There's only 1, 2, 3. So my choices are 3 for a second gray sock. And I no longer have 12 socks because one's on my foot. So I only have 11. So you have to look at it that way. You have to say, okay, when I don't replace them, I have 1 less. And if you're pulling from the same color, you're going to have 1 less on the top as well as on the bottom. So you have to really think about it in real life. Put yourself in that situation. Okay, then I'm going to simplify before I multiply. I can divide this first one both by 4. And I get 1 over 3. And then I'm going to multiply by 3 over 11. Now, I notice that I've got 3 over 3, a 3 on the bottom here and a 3 on the top. So there's a 3 here and a 3 here. I can also cross simplify, or you could just multiply. If I just multiplied, I would get 1 times 3 is 3, 3 times 11 is 33, and I would have to divide by 3 to get 1 over 11. However, I could also say, well, these 3's, if I divide them both by 3, are just going to give me 1. And then 1 times 1 is 1 over here. 1 times 11 is 11, and you still get the same answer. You can cross simplify as well as simplify your fraction before you multiply. All right, the other two you're going to try on your own for the quiz. Remember that if you're pulling socks of the same color, you're going to lose one of that color on the top as well as on the bottom. Good luck, and I will see you in class.